Hi! Today we're going to look at some properties of trig functions. And at the very top of your notes, you're going to see a blank chart, and you're also going to see like a unit circle over here. When we take a test, that's what I'm going to give you. I'm going to give you a blank chart, and I'm going to give you this little circle, you are going to have to be able to fill it in. Okay, so to the best of your ability right now, see if you can fill in everything you know about the chart, and then everything you know about this circle. Any points, like intercepts that would be useful, but then also like where things are positive and where things are negative. Okay, so go ahead and do that now. I'll do it as well, but just don't watch me. Okay. All right, you may still be filling it out. That's fine. I'm just going to talk. So make sure you can find all those ratios. And then also on the unit circle, what I did was I labeled the intercepts, because sometimes when you have an angle that lands on like the negative x or the negative y-axis, it may be easier just to look at this point and realize this is the sine of a negative 90 or a 270 degree angle that's negative 1, instead of trying to use the chart and then figuring out whether it should be positive or negative or what have you. And then also all students take calculus, which tells us where the trig functions are positive. Okay, so make sure you can do that. That's going to be really important. Now, the next thing we're going to do actually isn't going to use this over here, or actually any of this, but this will come in a little bit later. The next part you're actually going to have a little bit easier time with, because this is just going to be regular right triangle trig, because we're going to have points that are out in space but not necessarily on a unit circle. Okay, so if you look at this graph, this is a unit circle, has a radius of 1. This bigger circle is just some generic radius that we don't know. Okay, now if that's the case, if I don't know what the hypotenuse is, that's what the radius is, it's the hypotenuse, then it's going to change my trig functions a little bit. Like the sine is still going to be the opposite over the hypotenuse, but it's going to be the y value over, well, whatever the radius is. The sine would be the adjacent, which is the x value, divided by the radius. The tangent, now these two r's are still going to cancel each other out, so you're just going to get a normal y over x, which is what we're used to. And then these three would be those three flipped. R over y, r over x, and x over y. Okay? So this is actually going to be easier, because what you're going to do is, so what are the 6 trig functions of an angle that goes through the point 5, negative 12? So this is some point just out in space. Okay, it's definitely not on a unit circle. You would have those weird fractions. So we're going to go over 5, we're going to go down negative 12. So let's do that. Let's actually draw what this is going to look like. So 1, 2, 3, 4, 5, and then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going over and then I'm going down. This is my point. It is an ordered pair in space. Do not go 5 and put a point, negative 12 and put a point, and then connect those and get a triangle. It'll mess everything up. That's our point. This is an angle that goes through that point. Okay, so here's the angle. Remember, angles always measure back to the x-axis. Those are our reference angles. We always go to the x-axis. So watch what I'm going to do. I'm going to take this angle and I'm going to draw a line back to the x-axis to make a triangle. So now we have a right triangle. What do we know about this right triangle? We know this side is 5. We know technically this side is negative 12 because we went down 12. And then I could just use the Pythagorean theorem to find what this hypotenuse is. Okay, so 5 squared, negative 12, so 5 squared plus negative 12 squared equals r squared. This should be 169, so r is 13. So that's our other side. So if I were to ask you what's the sine, cosine, and tangent of this angle, well, you're just going to do normal right triangle trig. You're going to do the sine is the opposite over the hypotenuse, so negative 12/13. The cosine would be the adjacent over, so 5/13. And the tangent is, well, it's either these two divided by each other, or it's the opposite over the adjacent. Either way, you're going to get negative 12/5. Okay? Now, I'm also going to do the reciprocals, but before, look at the values. Look at how the sine ends up being negative because it uses the y value that was negative. The cosine, though, is positive because it's only using these two positive numbers. Your radius can never be negative. It is a radius. It is the length of the radius. It's always going to be positive. Okay? This just is negative because it has negative direction because we went down. Okay? But the cosine's positive because it's a positive over a positive. Well, that's what we would expect. We would expect that an angle in quadrant 4 has a positive cosine value, but negative sine and tangent values. If I wanted to know the cosecant, the secant, and the cotangent, I'm just going to take those three numbers and I'm going to flip them. So this is negative 13/12, positive 13/5, and then negative 5/12. That's it. You're done. How about B? Negative 1, negative 2. So first, I'm going to figure out where that is. So negative 1, negative 2. You're going to be in quadrant 3. So when I draw a picture, I kind of zoom in on that quadrant. Okay, I don't need to be able to see the other quadrants. I just want to see that quadrant right there. So negative 1, negative 2. So we're going to go negative 1 in the x direction. We're going to go down 2. That is the point, negative 1, negative 2. We're going to draw an angle. So we're going to go to the origin. We're going to go to the angle, or to the point. There's our angle. Always goes back to the x-axis. And then when I make a triangle out of this, I'm going to go back to the x-axis. Now, I'm going to label that triangle using these values, and I'm going to look at the direction as well. That is a negative 1, that is a negative 2. And I know, it seems a little weird labeling the side of a triangle as a negative, but that's what it is. Okay, negative 1, negative 2. So what's our hypotenuse going to be? Well, negative 1 squared is 1, negative 2 squared is 4. If I add those together, I'm going to get 5. So the hypotenuse is, let's see here, figure out how to write this. I'll put it over here, radical 5. That's our hypotenuse. So now I have everything I need. The sine, the cosine, and the tangent. Sine is going to be the opposite over the hypotenuse. So negative 2 over radical 5. Negative 2 over radical 5, which is negative 2 radical 5 over 5. That's the sine. Cosine is negative 1 over radical 5, which is negative radical 5 over 5. And then the tangent is negative 2 over negative 1, which is just plain 2. Okay, and that's what we would expect. We would expect that the tangent value is positive in quadrant 3 because tangent is positive in quadrant 3. Well, it's because the two negatives canceled each other out, and so we've got our two negative values, we've got a positive value, and now we can find the cosecant, the secant, and the cotangent as well by simply flipping these. Now, don't flip these. Don't flip your final answer. Go back to the original fraction before we rationalized it, because if you flip that, negative radical 5 over 2, it's perfect. It's already rationalized. So that's the answer we want. Okay? Same with the next one. Secant is going to be negative radical 5 over 1, or you don't have to write the over 1 part. And then the cotangent of that angle is 1 over 2. Okay? So try example C on your own. Draw the point, negative 3, 4. Draw an angle that goes through that point, and then go to the x-axis and make a triangle out of it, and then see if you can find the rest of the values. So you may want to pause the video so you can do that on your own. All right, that's what you should have come up with. Okay, so look at my triangle. So the point -3, 4 is in quadrant 2 because you're going left and you're going up, so you're going to land in quadrant 2. So there's my point. I then drew a triangle. I labeled the adjacent and the opposite side. I used the Pythagorean theorem to get the missing side. That was a 5. This is a 3, 4, 5 triangle. And then once I had that, it was just a matter of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, and then doing the reciprocals. Okay? All right, so on the back. We've talked about in the coordinate plane, we know that the trig function values as far as positive and negative change as you move throughout the coordinate plane. So you've got, they're all positive, the sine, tangent, and the cosine. See, my brain started to say sine, cosine, tangent instead of the all students take calculus. That's what I get for trying to talk at the same time. All right. Another way to look at that visually, you can kind of look at them one at a time. Sine is positive in the upper quadrants, and it's negative down here in the lower 2 quadrants, which again makes sense. Sine is your y value, so if the y is positive, the sine is positive, and the y is negative, the sine is going to be negative. Okay? Cosine is positive to the right of the y-axis, and it's negative to the left. Again, making sense since cosine has to do with the x coordinate. So it's going to be positive in the positive direction and negative in the negative direction. And then tangent is positive, like catty-corner from each other, and then it's negative in these 2 kind of diagonal quadrants. So 1 and 3 is where it's positive, and then 2 and 4 is where it's negative. So play a little game. If I told you that I had an angle and the sine of the angle was positive, would you know in what quadrant that was in? Well, the answer is no. I haven't given you enough information. If I tell you sine is positive, you can narrow it down. You can say, well, it's in one of these 2 up here, but I need to know some more information. So if you look over here, if sine of some angle is greater than 0, which is just a fancy way of saying positive, and the cosine of that angle is less than 0 or negative, now do you know where I'm at? Well, knowing sine is positive means you're up in one of these 2 quadrants, but once you know the cosine is negative, you have to be in quadrant 2 because everything's positive in quadrant 1, so you can't be in quadrant 1 or the cosine would have been positive. So you must be in quadrant 2. Okay, look at the next one. If tangent is greater than 0 and cosine is less than 0, what quadrant are you in? So knowing that the tangent is greater than 0 puts you in one of these 2, but then as soon as I tell you that cosine is negative, you've got to be in this one. This is where cosine is negative. So we are in quadrant 3. If sine is less than 0 and cosine is also less than 0, what quadrant would you be in? Well, 3. If they're both negative, sine and cosine, there's only one quadrant where both of those things occur, and that's in quadrant 3. Okay, last one I've got, sine greater than 0. So sine is positive. So boom, we've narrowed it down to 2. Sine is positive. And cotangent is negative. Well, tangent and cotangent are the same. So if I say cotangent, you can think in terms of tangent. Make your life a little bit easier. But if sine is greater than 0, but tangent is negative, less than 0, I must be in quadrant 2. Okay? Now, I could play this game all day long. I could just keep throwing, this is positive, this is negative, this is positive, this is positive, and you should be able to kind of tell where we're located. And that's we need to know how to do that for one of the problems we're going to do down below. So, if you look at the next section, I'm giving you some information. I'm telling you that the sine of an angle is -2/3. Well, if I'm telling you the sine of the angle, I'm telling you the opposite side and the hypotenuse of the triangle that angle would be in. So I'm telling you 2 of the 3 sides. If we drew a picture of this, we could use the Pythagorean theorem to find the 3rd side, and boom, I can find the 6 trig functions of that angle. So I need to draw a picture though. So to draw a picture, you've got to know where it is. Just knowing the sine of this angle is negative isn't enough to know where it's located. So then they're telling me, oh, this angle is in quadrant 4. Okay, so draw an angle in quadrant 4. So there's my angle, always up to the x-axis. That's where the angle is going to be. Never between the terminal side and the y, always the x. Then I'm going to go ahead and finish off the triangle. And now I'm going to label what I know. Sine is negative 2/3, so that's the opposite, and that's the hypotenuse. Now, that negative needs to go somewhere. Your hypotenuse can never be negative. That's like the radius of a circle. This opposite side, since we're going down, that should be negative. So that's where the negative goes. And now I just need to use the Pythagorean theorem to find where that missing side is. So that's going to be 3 squared, so 9, minus negative 2 squared, which is 4. So 9 minus 4, that's 5. So this is going to be radical 5. Okay? But now I can answer everything. Okay, find the exact value of the 6 trig functions. Sine, cosine, tangent. Well, we knew the sine was negative 2/3. Cosine would be radical 5 over 3. And then the tangent would be opposite over, so negative 2 over radical 5, which is negative 2 radical 5 over 5. Okay, so there's the sine, cosine, tangent. And then the cosecant would be the reciprocal of this, so negative 3/2. The secant is the reciprocal of this, so 3 over radical 5, 3 radical 5 over 5. And then the cotangent is the reciprocal of the tangent, which again, I'm going to look at this before I rationalize it, because once I flip it, negative radical 5 over 2, it's already rationalized. So you're going to find this probably to be a little bit more interesting, because you're not going to get those exact same numbers off the chart over and over and over and over. I can give you any triangle, a triangle that we can make, and then we can find all the trig functions based on those. Okay, so this will be a lot more similar to just the right triangle trig that we've already done, solving triangles. Okay, so B, the tangent of this angle is 1/3, so it's positive 1/3. So I know that this angle has to be in one of these two quadrants. Then they're telling me, oh, by the way, the sine of this angle that we're talking about is less than 0. It's negative. Okay, so that means I'm in quadrant 3. So I'm going to draw the triangle in quadrant 3. So there's my quadrant 3. I'm zooming in on it. I'm going to go to the origin. I'm going to go into the quadrant. I'm going to go up to the x-axis, always. There's my angle. Knowing the tangent means I know the opposite and the adjacent side. So 1 and 3, there's something wrong with that. If I'm in quadrant 3, these should both be negative. We're not seeing that negative because as a fraction, they're canceling each other out. So those are both negative. Okay? Pythagorean theorem, that squared is 9, that squared is 1, so that's radical 10. And now I'm good to go. Sine, cosine, tangent. Well, what's the sine? Negative 1 over radical 10, which is negative radical 10 over 10. Cosine is negative 3 over radical 10, or negative 3 radical 10 over 10. And then the tangent, well, we knew the tangent was 1/3. That means we also know the cotangent is 3. Okay, that's an easy one. Okay, these, as far as the cosecant and the secant go, again, remember, this used to be 1 over radical 10, so I'm going to flip that and just get radical 10 over 1. This was 3 over radical 10, so that's what I'm going to flip and get radical 10 over 3. And there you go. Okay, look at the next one. Now the next one they're telling you where the angle is. They're telling you a little differently. The sine of this angle is 3/5, and they're telling us our angle is between pi over 2, which is here, and pi, which is here. They're telling us our angle is somewhere in between those two angles. So they're just telling us our angle's in quadrant 2. It's just a fancy way of saying your angle's in quadrant 2. So draw a picture. Go into quadrant 2, come down, and now label what you got. 3, that's the opposite, and that's the hypotenuse. 3, 5. If you do the Pythagorean theorem, you're going to get a 4 here. But that's not right. It's negative 4. Okay, so make sure you're paying attention to direction as you're labeling things with the x and the y axis. All right, now I'm good. Sine, cosine, tangent. Sine, we already knew, 3/5. So we also know the cosecant is 5/3. That's an easy one. Cosine is negative 4/5. So the secant would be negative 5/4. I know I'm doing this in a little different order than normal. I'm just going back and forth. Maybe you find that easier. Okay, tangent would be 3 over negative 4. So negative 3/4. If something's negative, it doesn't matter where you put the negative. So if you write this as 3 over negative 4, you're good. If you just put the negative out front, that's good too. And then the cotangent would be negative 4/3. Easy peasy. Okay? Now, down the bottom, our book stops and kind of just wants to point out some of these identities. An identity is just a true fundamental thing that we've noticed. It's a true statement. Okay, you can think of that. Like the fact that cosecant it's called a reciprocal identity because it is the reciprocal of the sine function. So the cosecant is 1 over the sine function. Now that also means that sine is the reciprocal of the cosecant. But this is the way that's more helpful. Usually we know what the sine is, so then we just have to flip that, and now we have the cosecant. Okay, rarely are we going to be given the cosecant, and we're going to use that to find sine. Okay, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, those are just, they're called the reciprocal identities. Okay, we also have what are called quotient identities. Well, tangent, I've brought this up a couple times, but I haven't laid it out as far as what's called an identity. Okay, it's just the fact that quotient is a fraction. Tangent is the sine over the cosine. Again, you know this. That's how we actually create the chart. You know the sine, you know the cosine, now you know the tangent because you divide them. There's another quotient identity, and that would be the fact that cotangent, since it's the reciprocal of tangent, would be equal to the cosine over the sine. Now, what's going to happen next is they're going to say, okay, here's a situation. We have two pieces of information. We know the sine of the angle, we know the cosine of the angle. Can you find the other 4? Well, yeah. First off, you can find the tangent because it is the sine over the cosine. So if you take this value and divide it by that value, so 7/10 and negative radical 51/10, as weird as that value is, wherever that came from. Okay, this will reduce. Let the 10s reduce. You'll get negative 7 over radical 51, which is negative 7 radical 51 over 51. Okay, that's weird. Hey, I can throw whatever numbers I want. Okay, I took the numbers 7 and 10, I did the Pythagorean theorem, and I had to come up with this weird side of radical 51, so that's what it is. So that's the tangent of this triangle. But once I know these 3, then I know the other 3 because they're the reciprocals, right? So cosecant would be 10 over 7. Secant would be 10 over radical 51, negative, or 10 radical 51 over 51. And then the cotangent would be, I'd go back to this one. Go back to this guy. Negative radical 51 over 7. Okay. The next one, there is a typo on. Your sine and cosine have to have the same denominator. Okay, that's the hypotenuse. So they have to be the same. You can't have one triangle with 2 different hypotenuses. Hypoteni? Something like that. All right. So, again, if you know these 2, now you could go over to the side and draw a triangle, but we don't really need to. We just know that the tangent, I'll just put it up here, sine, cosine, tangent. The tangent is going to be this over this. So radical 33 over 4. See, and once you're familiar with these, you don't need to draw the triangle. You just go, oh, I can take this divided by this, and I'm good to go. Okay, and then the other 3, the cosecant, it's reciprocal of this, so 7 over radical 33, so 7 radical 33 over 33. Secant, reciprocal of this one. Oh, well, that one's easier. And then the cotangent is the reciprocal of this one. So 4 over radical 33, which is 4 radical 33 over 33. Okay? So a lot of little random pieces of stuff. So make sure you use your notes and look at the directions on each question on your homework and make sure you're matching them up and you know exactly what you should be doing. Okay? As always, let me know if you have any questions.